Okay, great. Good day, good afternoon, everybody. Welcome to Klaymakers22 Developer Workshop. Klaymakers has kicked off and you can now start submitting on DoraHacks till September 30th. And we have a lot of workshops prepared for you until September 12th. And today we have Colin from Klaytn Core development team. He's head of core development to talk about support of Ethereum Equivalence. Can you go to the next slide? But before we begin, I'd like to acknowledge my gratitude to all of our sponsors and community partners for making this happen. Next slide, please. Just to recap, Klaymakers22 Hackathon is Klaytn's first global virtual hackathon, and the prize pool is at 360K. You can participate in one of the 5 main tracks by Klaytn Foundation, and also in 6 sponsored challenges and win Clay or US dollars. So you can check out more information on our landing page or scan the QR code, which will be redirected to our Discord channel to leave any questions or any comments. Okay. Okay, like I said, if you have any questions, any comments about this session or previous sessions, you can scan the QR code and leave your questions there. Now, without further ado, I'll pass it over to Colin, who will now talk about support of Ethereum Equivalence on Klaytn.
Okay, thank you for the introduction. And can you hear me? Good? Okay, yeah, good. So my name is Colin, and I'm leading a core dev team in Klaytn Foundation. So in this session, I want to talk about Ethereum equivalence, how we achieve Ethereum equivalence on Klaytn. So on the right-hand side, you can see the QR code. When you scan this QR code, then you can see this presentation file. So I will go through some tutorials after end of this session. So it could be better you check this slide together. So this is the outline of my presentation. First, I want to discuss what the Klaytn is and how we achieve the Klaytn. In terms of Klaytn, how do we achieve Ethereum compatibility and Ethereum equivalence? And then I will have some hands-on tutorial sessions so that you can check real Ethereum application, Ethereum ecosystem tools can be used with Klaytn together. So let's talk about Klaytn in a nutshell. So actually, when we launched our Klaytn mainnet named Cypress, we have some terminologies, and these terminologies can be make a worldview of our Klaytn. So as you might know, Klaytn logos are changed a little bit, and as you can see here, the color of this logo is mixed of orange or red colors, and this color comes from magma. So in the baseline layer, we have magma, and on top of the magma, we have crust. So currently, I'm working with Crust Universe, which is a subsidiary of Kakao, and so the crust is a thin layer that just covers the magma. And also, actually, crust starts from C, but we changed C to K because our company name, my mother company name, is Kakao. So crust, and then on top of crust, we have GroundX. GroundX is a company name who developed a blockchain platform at the first time, and the ownership of this development is transferred to Crust Universe. So Crust and GroundX, and on top of GroundX, we have Klaytn. This is our blockchain platform name, and this Klaytn also composed of 3 words: K plus clay plus stone. So Klaytn composed of K plus clay plus stone, and those clay and stones are on top of our GroundX. And with clay and stones, we have a name. We have a tree named Cypress. And besides Cypress, we have 2 important ecosystem tools, such as KaiCas and Caper. KaiCas is a wallet name, and the name comes from God of Wind in a myth. And also we have Caber. This is a SDK, and the name comes from a gentle breeze in the Hebrides. And on the right-hand side, we have some characters. So with these characters, we'll make a kind of a story to discuss and explain this worldview of our Klaytn. So basically, we have 5 characters here: core developers, governance council members, ecosystem developers, and service developers, and Klay holders. So please stay tuned, and around end of this year, we will publish our Klaytn story. So that's it. And actually, blockchain platform Klaytn is developed by Kakao, and there are many supported companies like GroundX, Kakao Investment, and Crust. And also, as you can see on the right-hand side of this slide, there are so many ecosystem partners and services and tools and various sections like DeFi, gaming, governance council, wallets, and so on. As you can see, there are so many. So we are kind of making more robust blockchain ecosystem together. And Klaytn blockchain offers many features. I will discuss a little bit by each one. And first one is speed and reliability. So I will discuss a little bit more in the next slides, but basically we achieved 4,000 TPS when we launched our mainnet. And this is not a theoretical performance. This is a real performance we measured on real network infrastructure. And then our blockchain block generation time is 1 second with immediate finality because we use BFT consensus algorithm. And in terms of flexibility and customization, we provide our service chain solution so that you can make your own blockchain platform with our Klaytn technology. And also we are making hassle-free management so that you can make more ecosystem. I mean, we will provide more ecosystem tools along with the service chain so that you don't need to make your own wallet or your own chain explorer or other things. We will provide all the things together with an open source version of packages. Actually, this is not complete yet, but we are making more open source packages together. And then we expect that end of this year, we will provide all the packages together so that you can easily build your own blockchain platform with Klaytn technology. And fee delegation is another good features with our Klaytn technology. So you don't need to make gas station or other things. We added our transaction model. So you just add your fee payer's address or signature address and signature together, then the fee will be charged by the fee payer. So it's very easy to use, and you don't need to change your smart contract from message.sender to message sender function. You just use this fee delegation mechanism on the platform layer. And also we are trying to make cost predictable, because transaction costs can be vary in many different blockchain platforms. So when we launch our mainnet, we wanna make fixed gas price, but these days we change a little bit so that the gas price can be a little bit dynamically changed. But we do not wanna make this dynamic price range can be higher. So we make lower bound and upper bound of our transaction fee cost, so you can a little bit deterministic your gas cost. And the last one is frictionless implementation. So after we achieved Ethereum equivalence, so you can use any Ethereum development tools with Klaytn together. So it's very easy to integrate your application or ecosystem tools with our Klaytn. Yeah, so performance and finality are very important for Klaytn ecosystem. So as you can see, there are many blockchain platforms here, and many blockchain platforms, their blockchain time is less than 10 seconds. But actually, this just shows the theoretical specs. But more important thing is actual user experience. So for example, when you click the application, then you get response when the action is completed. So this is just a block generation time, but it does not describe how long it will take when you click the action. So we measured transaction latency from all the other blockchain platforms together. So we measured transaction latency on every minute so that you can check this slide here. So Klaytn shows very low latency compared to the other blockchain platforms. So when you make a signed transaction and then submit this transaction to the network, and we wait until the transaction got received. So basically, we measure this this time, and on average, a week of average, we got 2.1 second of transaction latency on average for a window of 1 week. And as you can see, that the other blockchain platforms are more than 3 or more seconds. So Klaytn shows the lowest transaction latency compared to the other blockchain platforms. Oh, yeah. Also, you can check this experiment and articles in the URL at this end of this, bottom of this slide. So you can check how we measure the transaction latency and the source, how we make this source code. This source code is already open, so you can check how we can make this experiment. The latency is the only one we need to consider. The other thing is stability of transaction latency. So, for example, when you send a transaction for this time, then you take about 2 seconds when you get a receipt until when you get a receipt, and the next time when you need to wait 10 or more seconds. Then you cannot expect how long does it take. 2 seconds is right or 10 seconds is right. So stability is another important thing for in terms of user experience. So the above chart here shows the transaction latency of a week period on Klaytn. So as you can see, Klaytn shows very stable latency. So there are some small outliers, but mostly the transaction latency are from the range of 1 second and 3 seconds. And the below chart shows the other blockchain platforms transaction latency. So as you can see, they're very different transaction latency. So it's not easy to expect how long does it take when you execute a transaction onto these type of blockchain platforms. So what I want to discuss and make you guys understand is Klaytn is focusing Metaverse blockchain. So to Metaverse blockchain, actually transaction latency and stability is one of the important things for better usability. So Klaytn shows lowest transaction latency and good stability compared to other blockchain platforms. So we can say that Klaytn has better usability in terms of transaction latency and stability. So please try to implement any blockchain applications on top of Klaytn. So this is just a result. So you need to know how it is possible, right? So I know a little bit more about the technical details of our blockchain platform. So in this slide, it shows the network architecture of Klaytn and Cypress, and also you can make your own blockchain platform with our service chain solution. So in the middle of this slide shows our main network architecture, and in this architecture we have 3 types of nodes: consensus node or CN, proxy node or PN, endpoint node or EN. So as the name insists, consensus nodes are basically running their consensus mechanism, so they make their own blockchain, their own blocks, propose blocks and validate blocks. So they are mostly focused on making blocks and making a consensus. And proxy node, as the name indicates, that this node will propagate blocks to the from ENs from CNs to ENs, and also they are gathering transactions from ENs and propagate those transactions to CNs. So this PN is kind of buffer between EN and CN. EN endpoint node, this endpoint nodes basically provide API services to blockchain platforms on Cypress. So you need to, if you need to send a transaction or get any information from contract, you need to connect any EN, and then you can get data or send a transaction through this endpoint node. And also you can make various configuration of our service chain solutions. On the right-hand side of this slide, you can see the similar network architecture compared to the Cypress. And you can make this kind of complicated network architecture if you want a more stable and more performant blockchain network, or if you just want to make a toy network with testing or experiment of our blockchain platform, then you can make a small network architecture like left-hand side of this slide. So you can make two SCNs, and you can make your own architecture, and you can experiment your services on top of this small service chain. So with this architecture, we can achieve 1 block generation time and about 2 seconds of transaction latency. So I want a little bit dig deeper of our Klaytn architecture. So we have basically Ethereum EVM execution environment, and we have Istanbul BFT consensus algorithm, and we have 1 second block generation time and instant finality due to this BFT consensus algorithm. And also we provide service chain architecture so that you can make easily your own blockchain network. And we have 3 types of different node models, CN, PN, and EN, which I discussed in the previous slide. And also we changed the account model and transaction model so that you can easily change your private key to your account so that you can increase your account security. Also, we changed our transaction model so you can make very easily to field delegation functions, and also you can make multiple signature fields in this transaction model, so you can utilize your multi-sig account in the platform layer. And I wrote like here semi deterministic transaction cost model, which means in the previous I discussed previously. Actually, for the first time we did a fixed gas price, but recently we changed a little bit to dynamic gas price mechanism, so that it's not it's not completely deterministic, but semi-deterministic transaction cost model. And this is a little bit deeper node architecture. I mean, source code of single node. So Klaytn started as a fork of Ethereum in June 2018, and at that time we make a change a lot to increase the performance and increase usability or user experience. So basically we are forked from Ethereum, but we changed a lot for better use cases on the Klaytn ecosystem, such as on-chain multi-sig account and field delegation transaction model, and so on. But there have been a problem of compatibility issues between Klaytn and Ethereum, because we have divergent data structures, which gives rise to compatibility issues with tooling and other interfaces. Also, you can check the details of this description of Klaytn architecture in the link at the bottom of this slide. So we need to Ethereum compatible to utilize Ethereum tools together. So these days, Ethereum has been the de facto blockchain platform for applications, and its network effect is growing larger and larger. There are so many use cases, and there are so many development tools on Ethereum ecosystem. So there are many other blockchain platforms that tend to support Ethereum compatibility in some way, like they're changing their core protocol, or they are making another chain to support EVM, and so on. So we need to also try to do something like that. And it takes some time, but we are trying to make this approach together in the beginning of this year. And also, there are many topics related to Ethereum Compatible and Ethereum Equivalence. So EVM Compatible is part of alignment with Ethereum virtual machine specification, but EVM Compatible is not talk about EVM Equivalence, which means you need to modify or even completely re-implement the applications if we just make Ethereum Compatible blockchain platforms. So EVM compatibility is not the same as EVM equivalence. So try to utilize Ethereum's wave of infrastructure and network effects together. There are many other blockchain platforms try to support Ethereum compatibility. But as I told you before, Ethereum compatibility is not enough. So we need to make Ethereum equivalence so that Ethereum's tools can be easily used without any modification. So Klaytn 1.0, until the last year, we just emphasized more on our features and data structures than Ethereum compatibility. So we are focusing our own features. So we did not keep up with the latest EVM versions and interfaces. So there are some semantic changes between the Klaytn and Ethereum. So which makes application developers need to put much more effort to port or integrate Ethereum dev tools or applications with Klaytn. So it's not easy to make. If we do not support Ethereum equivalence, then you need to make your own adapters based on your applications. So we make many different types of adapters to work on Klaytn together. So it's not easy job to do. So we need to achieve Ethereum equivalent so that you can use this kind of single adapter, which is implemented by us. Then you just use Ethereum ecosystem tools right away. So Ethereum equivalence means we have to provide complete compliance with Ethereum virtual machine specification. So you can use any Ethereum tools on top of Klaytn together. What about others? Actually, other blockchain platforms are also trying to support Ethereum equivalence or Ethereum compatibility, like this Cosmos and Near, Solana, Polkadot. They are all trying to make a compatible version of EVM so that Ethereum applications are easily ported on top of their blockchain platforms. So same thing, we discussed this very beginning of this year. So actually at the beginning of this year, we announced Klaytn 2.0, and Ethereum EVM equivalence is a pillar of Klaytn 2.0 initiative. So we are trying to focus 3 types of items to make Ethereum equivalence: EVM and its API, and development tools, and core development contribution. So we did not achieve all the things right now. So we are also focusing on make more support of Ethereum equivalence. But anyway, Klaytn 1.8.0, which was released on March 31st of this year, we achieved EVM equivalence so that you can use any Ethereum applications or tools on top of Klaytn together. So since of this first quarter of this year, you can use any Ethereum tools together. How did we do that to make Ethereum equivalence? So actually in the node side, we have 2 different parts: Ethereum equivalent parts and Klaytn specific parts. So we provide this JSON RPC API namespace. So using this namespace, you can use Ethereum tools without any modification. But we have our own features and different data structures. So we need to provide our own specific features with this Klay namespace. So we have 2 different parts, and each part supports different dev tools. So that's it. And I want to talk about a little bit of implication of implementing EVM equivalence. So there are many things we need to consider to support this EVM equivalence. So we need to keep up the latest version of EVM and transaction types on other things and precompiled contract together on Ethereum. So it's very hard thing to catch up all the different things which is already done in Ethereum onto the Klaytn. And also we have some development tools applicable for use with Klaytn ecosystem. So actually, we have been supported. We have been provided if namespace before, but the API format was different from the Ethereum. So we need to fix and match the API request type and response type so that Ethereum development tools can be used without modification. But also we have our own transaction types with Klaytn, so we need to support both Ethereum formatted transactions and Klaytn formatted transactions. So we need to provide those type of RPC formats in two different transaction types with two different API namespaces. For example, for ETH namespace, we provide same RPC interface with Ethereum, but Clay namespace, we have to provide our own blockchain, our own transaction formats. And also to do that, actually, we have two different API namespaces, and each namespace has different semantics and different API request and response formats. So it's not easy to adapt Ethereum's latest states on top of Klaytn, but we need to provide that so that Ethereum tools can be used together. So I want to talk about a little bit more of the change we did for this Ethereum equivalence. Actually, we made 3 new precompiled contracts for our Klaytn blockchain platform, but the address are just after the previous precompiled contracts. But also Ethereum make more precompiled contracts, so the addresses are conflicted together. So to support Ethereum applications as it is, we need to change our precompiled contract addresses to support Ethereum. So we changed the addresses like this. For example, VM log address was 09, but it is changed to 3FT. And actually, when we launched our mainnet, at that time, Ethereum has only one transaction type. So we support this transaction type, and the other transaction types are designed and implemented by our side. But Ethereum also, they make other transaction types. So there should be some conflict. So we make our own, actually type numbers are conflicted from Ethereum transaction types and Klaytn transaction types. So to support this one, actually on the right-hand side, as you can see that Ethereum transaction types are supported as it is when you use ETH namespace, but when you want to use Klaytn namespace, the Ethereum transaction types are the RLP format is really different compared to the original Ethereum transaction type. So to support those things together, yeah, we need to make kind of this policy to support both blockchain platform and transaction types. Okay, yeah, so I discussed all the technical details with you guys, and if you wanna build any blockchain applications with Klaytn, you can check out this QR code. You can scan it, and you can check our blockchain platforms. And I want to talk about a little bit more of our Klaytn. So Klaytn is 100% of open source core development. So when you go into this GitHub repository of our Klaytn organization, you can see our old development exercises and activities in this repository. So, and we are also making more dev infra packages like SDKs and contract libraries, all the things together. And also you can check these open source packages in this organization. Actually, it's not completed yet, but we are trying to make more infra packages. And also we are providing all other things like dev onboarding toolbox and tutorials and ecosystem funds and opportunities to discuss Klaytn team and dev communities. And yeah, this is just for hackathon, right? So Klaymakers, you can, we are running our own hackathon, so you can implement your ideas with this hackathon. So this is a hackathon workshop. So I wanna have really hands-on tutorials. So please download our this slide, and you can check some other links, and you can follow my tutorials. Actually, we don't have much time. I will not do live coding, but you can follow the instructions in this tutorial so that you can use how Ethereum and Klaytn can be used together. So this hands-on tutorial session, I want to discuss two things. First one is hands-on examples on Ethereum API, and the other one is hands-on examples on Klaytn API. So let's go first, hands-on examples on Ethereum API. Most common SDKs used with Ethereum are Web3.js and Ethers.js. So you can download these examples. I will show a little bit on this. So you can see there are two JavaScript examples here. So yeah, Ethers and Web3.js. So in the Web3.js code, all the things are exactly the same, but you need to change only this RPC URL and Block Explorer URL. You just set only those two things, and you can change Ethereum. You can also access Ethereum network, or you can access Klaytn network. The source code, there's no difference. And also Ethers.js, same. Okay, it takes some time. Yeah, great. So same, you need to set up this RPC URL and a Block Explorer URL, and the other code are just exactly the same. You don't need to change anything. Okay. So what you need to do is just download, clone this repository and npm install, and you just copy this environment variable and you update your private key. And then you just run these examples with Node.js. And that's it. Then you can check. You don't need to change anything. You just do the same thing with Ethereum. Yeah, this slide shows there's no difference. Also, I want to talk about a little bit more about other tools, not just SDK, but we have frameworks to easily implement our decentralized applications, such as Truffle and Hardhat and Remix. So they're a very simple example, and I will not do live execution, but you just checked here. So you can check out this link about explaining how to use Truffle, and you just set up your node version, and you need to install Truffle, and using this unbox execution, then you can make your own Truffle execution environment. And then you need to install one more thing for Klaytn, Truffle Hard HT Wallet Provider. So with this one, then that's it. What other things you need to implement? You need to install. So more description of this installment, you can check out this link, and then you can see how to install on different versions of Node.js. Yeah, okay. And we are also trying to build our online toolkits with this URL. So you can check there are many online toolkit examples. We are currently implementing some features. We've not done all the features here, but in this example, you can generate your key store file. So using this, you can make your own private key here. And then, yeah. And then you can make a private key. And with this address, you can get test Clay with our faucet. Our faucet is also, you can go our faucet with this URL and our Klaytn wallet web service. You just put your address here, then you can get Clay, test Clay. Okay, and that's it. And only the one thing you need to do is this configuration. So in the previous slide, you install this package. So you add this package as required, and you need to add Baobab network like this. And that's it. You don't need to change any other source code. You just need to change this configuration file. And then you can run truffle deploy network Baobab. Then the contract will be deployed on our Baobab, which is our testnet. Okay, and the other example is Hardhat. So I will discuss this one together to deploy a contract on our Baobab test network. So to install Hardhat, you just to execute this one. So install, and you can set up some Hardhat configurations by running npx Hardhat. And then you need to set up this Hardhat network configuration. It's very similar. You just set up this Baobab URL and accounts, then that's it. It's much more easier compared to Truffle. And that's it. And you can execute your contract deployment with this network Baobab. Then you can deploy your contract with this Hardhat for Klaytn network. And the other one is Remix. Yeah, Remix is a smart ID system on web service as a web service. So to use OpenZeppelin wizard, you can see this kind of configuration. Then after you configure all the features you want, then you just click this open in Remix button, and then Remix web service are opened like this, and you can install Klaytn plugin with this Klaytn docs. So yeah, you can follow up this tutorial, then you can install Klaytn plugin, and you can set any network environment you want. And then, yeah, and then you can see here Klaytn plugin, and then you can use Remix web service just same as when you use in Ethereum network. That's it. So there's no difference actually. You just need to set up a configuration of our Klaytn endpoint URL, and that's it. So far, so easy. And then I want to talk about a little bit more about the Klaytn specific features. So there are many Klaytn specific features, but in this time, I want to discuss only two items. First one is decoupling key pairs from addresses. And second one is fee delegation at the platform level. So different from Ethereum, we decouple the key pairs from addresses, so you can change your private key to your account, which is different features of from the Ethereum. So you need to check the design and implementation of our Klaytn architecture. So by clicking this link, then you can see the what can we do with this feature. Yeah, and then actually this is just a design, and this does not tell you how to implement this account key update mechanism. So I added two URLs here, two links here, so that you can check how to implement using Kver.js, JavaScript version of our SDK, and Kver Java version SDK. So when you click here, then you can see three different type of key types. So public key type, role-based key type, and multi-sig key type. So each key type you can check how to change your account key. Yeah, then sorry, exactly the directory architecture are the same. So Java examples also, we have three directories, and each directory describes how to update your single public key or multi-sig mechanism or role-based keys. Oops. Sorry for that, but you can check the link later. And then also fee delegation mechanism, how to make this fee delegation mechanism. You want to know more about fee delegation, then you can check our Klaytn docs. So in this Klaytn docs, you can check how the transaction format looks like. And then also you can check our examples for Kver.js here. Yeah. And for Kver Java, see here. Okay, then that's it. And yeah, we have many other examples with this repository named Kver.js examples and Kver Java examples. So you can check out other examples with this repository, and you can copy any code snippet if you want to use for your application. So I think that's it. And when you scan this QR code, then you can check our many other web services or SNSs or our Discord channels together. So please scan this QR code and yeah, find more information about Klaytn. Okay, so Terri, do we have any questions in the chatting or?
Let me check.
Mm-hmm.
Okay, if you have any questions, you can leave them in the Binance Live comments. While people are sending Colin coffee and flour. So far, I don't see any questions.
Okay, I will answer questions if you leave any questions there. So let's go to other things. Terri?
Okay, so that was all for Colin's presentation on Ethereum Equivalence. Thank you so much for your thorough explanations and the demos. And the Klaytn specific features are also very interesting. And we also have more workshop sessions coming up. Can you go to the next slide? So these are the workshop sessions that we have planned. The previous ones are also available on YouTube and Binance Live. And we have a few more coming up left until September 13th. Can you go to the next slide? Yes, on September 6th, we have GroundX challenge workshop, and then followed by service chain tutorial and zero knowledge proof from Klaytn. And on September 13th, we're going to have a workshop session on the grants and the opportunities for the winners of Klaymakers Hackathon. So it's going to be very exciting, very interesting for all of you that are participating. So you have about a month's time to submit your BUIDL on DoraHacks. So we very much look forward to your creative ideas. Okay, if you have any questions regarding this workshop or previous ones, or regarding the process of our hackathon, feel free to scan this QR code and visit our Discord and leave your questions, your inquiries, your comments there. Is that the last slide? Okay. Thank you so much for watching, and we'll see you again at our next workshop. Thank you.
Thank you.